to give you, I have a few slides on introduction, right, to set the stage a little bit. But so if you look to me, where we are coming from is, these days we are all talking about APIs, right? And for me, the big reason is that today a lot of these things have been operated by humans, and we want to actually go to a mode where we can do what we call self-driving and self-managed networks, right? And as a result, APIs is a critical component to achieve that, right? And the reason why I have this slide is a little bit, I think what has happened, at least from my perspective, is that we had two parallel activities happening in the industry. One was coming from the IT side, which developed OpenAPI, right? And they basically use OpenAPI for all the things. So if you look to Kubernetes, for example, it actually uses OpenAPI as a way to express all the schemas. But we see that there has been another industry in parallel, right, which actually developed a similar protocol, which is called Yang, right? So it's basically a way to express or to model an API, if you will. And if you look to Yang, where it came from, so if you look, it's actually a technology developed inside of IETF, right? So, so we had SNMP, so it's basically a next generation of SNMP, which has a certain characteristic. So I listed a few of them here. So there is a few RFCs. In the meantime, we have Yang 1.1, right, which seems to be the way forward. But in essence, Yang is a modeling language, right? So where you can basically express what your API does, what are the minimum and maximum value a certain parameter support, or all kinds of constraints that people come up with that your API expresses, right? And so if you look, there is several SDOs that are basing themselves on Yang. So you have one, I think you have two extremes. You have on one end the IETF, that was the origin of, or where Yang is actually being developed and so on. And they, besides Yang as a modeling language, there is also a set of protocols. So in IETF we also have netconf and restconf as a protocol to actually consume Yang as a transport, right? And then on the other side you have OpenConfig, which is basically another initiative that also uses Yang and uses Yang as a modeling language, but also developed a protocol called GNMI to actually transport it and consume it, right? And then they also developed streaming telemetry using GNMI. So in other words, and then you have Broadband Forum and 3GPP that actually more on the modeling side, and probably there is a few SDOs that I'm missing here, but you see this is kind of a little bit the landscape that we have to deal with somehow. So you see that I think the audience of this conference is actually active in all these domains somehow. So you see that it's applicable in both wireless, fixed access, networking, and so on. So there is a bunch of industries that use it. There is some differences between these protocols, right? So if you look to netconf, it's an XML-based stuff. So I think Tal yesterday said XML is dead, but unfortunately, I don't think that's completely the case. Although I would love it to disappear. There is alternative, so restconf is basically then more JSON-based, and then in GNMI you have then protobuf and so on and so forth. So there is some various differences between the different protocols. But in essence, what you see is that the industry as a whole adopted combinations of these, right? And so as a result, when we did this project, we kind of said, although we don't do restconf at the moment, because I'm of the opinion that once you go, so restconf is a little bit more on the orchestration side. So given that I'm very active in Nephew, so we are more a believer to use OpenAPI and that whole ecosystem, rather than trying to come up with another alternative, and I think that ecosystem is way bigger than the Yang tooling, and if you look to the whole thing around it, so that's why I'm a firm believer that that layer we should go to Kubernetes and APIs and KRM, but we have to have a mechanism towards certain devices that have been adopting Yang in their systems. And that's the place that we are talking about. So what we are seeing is that there is a various set of elements, and I classify them as PNF, so there is physical systems, or virtual machines, or containers that actually have Yang capabilities. And so there is like networking, mobile, fixed access, Wi-Fi, and probably I'm forgetting certain things, but what you see is that there's a wide spectrum of systems that actually have Yang capabilities. And then the question is, can we, let's say, consume Yang in what we call a cloud-native way, right? So that's kind of a little bit what we are trying to achieve or discuss here, is we have this discussion. So Yang, if you look under the hood, is an imperative protocol, right? So it's basically, you have a set of procedures. And the key challenge that we were facing, given that we are doing a lot of work in Nefio, but in general on a declarative consuming a system, a declarative way of consuming the system, the question is, can we do it? So I was told, even before the session, that some people are skeptical around that. And I hope with the session that we can prove them wrong after this. But so that we did an open source project. So this is an open source project that is available for people to consume. It's called SDC, so it's schema-driven configuration, right? And its aim is basically to manage or express or interact with a device that is Yang enabled in a declarative way, right? And if you look to a declarative system under the hood, what you see is that, in my view, the way I try to explain it always, it's a big diff that you do, right? So you get a demand of a certain configuration. You have to compare it with what you have in place. You create a delta, and then you transact, and you try to get the desired, so the desired state and the actual state at the same time. So in other words, you have to do quite a number of operations, and of course, depending on the system that sits on top of it, you might have, so there can be quite some churn to be able to interact with that, right? And so my first attempt, which is 5 years ago, to solve this, I basically had a diff system, so I actually killed the box all the time. So and of course, if you do lots of change, you do a lot of get and list, and so you interact with a device like continuously, right? So this was a challenge, okay? And then we said, okay, so we have to build a layer in the middle to actually only transact or try to interact with a device when we really need it, right? So what we did, if you look to the way the system is architected here, there is basically 4 components. There is, the first one is the config server, which in essence is actually a mediation between Kubernetes and the actual system that does the job, right? There is the data server, which is actually it's actually a proxy between the, let's say, the API on top, so the Kubernetes system. It's actually using gRPC, and the real device, right? So the way the data server works is actually how a real device works under the hood. So in other words, when you do a change, it creates a candidate configuration. It basically interacts with the schema server. And so the schema, it fetches the schema that is related to that particular vendor or that device, right? And it interacts with the cache, which actually has the data of the device. So the cache is actually it's actually a copy of the real device. So if you go to the cache and you ask, and I'll show you, I hope I will show you a demo. So if you go to the cache, you actually see a real device, and in the cache we store the running config, the intended configs, as well as the state. Okay? So in other words, when you get a new intent or you get a new configuration, what actually happens, the data server builds a candidate, it goes to the schema, it goes to the running config, it does actually what the real device does, and then if the validation fails, it will say, I cannot do it. So basically, you will get an error with the right information. If you can do it, it will then calculate the delta and then only transact the pieces that are needed. And if that succeeds, we are happy. If it doesn't succeed, we actually roll back, right? So in other words, you actually create. So if you look to the data server, because one way, so there is a set of people that want to consume the system, so the data server and the schema server and the cache inside of the system itself. So the project itself, there are some people who are actually using the code or try to use the code to implement it on the device itself, right? But we are using it here as a way to help the automation and orchestration type of environments as such. It's designed to be multi-vendor. Now, our experience tells us that Netconf as a protocol and GNMI, not everybody adheres to all the standards, and everybody has its own little quirks. But so we are trying to accommodate for that. So I'm not saying that every vendor is 100% supported at this stage, but the project aims to be doing this in a multi-vendor fashion. And we support southbound at the moment, both GNMI as well as Netconf. The other thing that we implemented, which is is worth discussing, is that we see two usage of how people would consume the system. One is they calculate the full configuration of the device, and then they transact with us. So what I call the full config. But in a lot of cases, what people do is Yang is a big tree, right? So there's a lot of stuff that is under the hood, right? And so a lot of orchestration systems say, I'm only taking care of the interfaces, this one about this piece of configuration, and so on and so forth. So it's possible you get conflicting information, right? So how do you deal with that? So we tried, so the way that we do this is, and that's what I call config snippets, is the system for every path in the tree that we get, so when you get an intent, there is a priority that you can set. And if so the highest priority wins. And if you get the same priority for that intent, it's the first one who we got, that's the one that we transact. But so for every delta that we calculate it based on all the intents that are available. So in other words, on a per path or per leaf, we will actually figure out who is to resolve the conflict, and it's also deterministic. Right? So that was a very important aspect, because what we've seen is that we could have done two things. We could have said, okay, you could not do that at the upper layer, but reality shows us people will use it in various ways that we haven't really intended, and we want to design it in a way that it's deterministic and that we have a mechanism to resolve the conflict, right? So that was an important, and I think that's a very nice, I believe a very nice way. Of course, it's from our side, a lot of complication that is in the system to actually accommodate for that. Now, each of these components are built as a set of microservices itself. So in other words, the current version that you see in the open source, what we did is it's all in one pot. So it's basically all put together. So basically, it's a single pot in which both config server, schema server, data server, and cache runs. But it's also what we see, there is certain scenarios where, and I'll have a slide about that, where people want to use it in scaled out. So you actually manage thousands of devices using a single component. So you want to actually scale out the system. So it's basically designed to accommodate for both a scale in and scaled out system. And so the schema server data, so you see here on the slide, so it's used gRPC in between. So you actually can scale out each of these components independently. And to make it work in a scalable way, right? So, yeah, so that's what is here. So now we went a little bit, so there's a few things that we added. So in the config server, as I said, it's mainly an API gateway towards the system. So if you look to the CRD or the CR that you see here, the way it is operated. So first of all, it's implemented as an API service, so not through etcd. Okay, so why is that important? is that certain YANG files, so for example, one of the, so we have a configuration ISO which is NTT in Australia. It's 3 million lines. Okay? Scary, but we wanted to support that. If you look at YANG schemas as such by itself, they are sometimes bigger than what you can store in etcd, right? So we had to deal with that. So as such, this system is leveraging the API server capability of Kubernetes. So in other words, we store, so the storage layer that we are using at the moment is, so we're using BadgerDB, right? But we can change it to other storage systems, but BadgerDB seems to be a very scalable way to leverage here. And then, so that's one important thing, but the system also has some additional capabilities. So there is a CR, so what we have seen is we need to get a schema, right? Not everybody, for example, in GNMI, there is no way at the moment you can fetch the schema, right? So we added a capability. So what you see in certain industries, like in networking, all the schemas of all the vendors, they are available on Git, right? So what we did is there is a CR, so there is a CRD, which is a schema CR, so where you can basically say, here are the vendor, this is the version of the schema that you want to use, and you basically can download the schema from Git, right? So there is a capability to do that. The second thing that is there is a discovery mechanism inside. So in other words, we can basically say, here's an IP range, go and figure out which devices are on the block, but we can also, given that we use Kubernetes, we can also use services and pods to find the IP and as such connect to it. So we need a way to, we wanted to find a way to easily connect to a device and figure out which systems that we have to interact with. So that is a discovery controller. And then there is a target that is being used to connect to the device, if you will, right? Now, I don't know, I prefer to show a demo, okay? And I hope, so this is live, by the way. So this is a system that is, so you see there is basically, the config server is running. So you see here there is two, yeah? We don't see. Oh, you want to make it bigger? You see, but it's not big enough. Is this better? Right? Okay. So you see there is a config server that is, so there's a single pod with two containers. So one container is a config server. The other one is actually the combination of data server, schema, and cache, right? So this is what we call the simple deployment here. And then I have a system here. So basically this is, we support at the moment two types of, so there is config and there's config set. So one of the requirements that we were asked was, we wanted to have an ability to have the same configuration apply to multiple devices at once. So that's the typical way that Kubernetes operates. So that's what a set is, but a set is basically just a replication. So if you look to the CRD, which you see here, we use a target selector, right? So every device with that label is going to be taken, and then we transact that to the device, right? And so what you see is that the way it is modeled, so any configuration knob that you actually have in your YANG model, you can actually map to, right? So in other words, we don't model inside of the CRDs in Kubernetes or the CR in Kubernetes, we don't model YANG. YANG is kind of a blob, right? So basically you have a CRD and then you have a blob of data, and that blob of data, which is actually under the value, so this is actually the YANG data that actually the device that goes to the device, right? And you say it's from the root path here, and you can have multiple snippets inside of your CRD, so it's a bit flexible as such to leverage, and here is your priority, and you can have multiple of these paths into your CRD. So what I wanted to show you, the declarative operation is the following, right? So you see here, I did a configuration of interface Ethernet 1.3. So here I have an Azure Linux type of system. So this is a Nokia system. If you go, so you see I have interface 3. So if I would change this to 2, right? which means that you have to delete all the interfaces, and then recreate it and stuff like that. So it's always the fun operation. Here you go. So now you see it's changed to 2, right? And if you look to, so basically it had to calculate the delta and do all the diffing and stuff like that. So and it does this across all the system. You also have an ability to, for example, if you want to get running config, right? So I have 2 devices into the system. So if I say dev1 or dev2 minus or YAML, you get the full running config of the box, right? So, yeah, Alexis, you have a question? Or?
How do you manage brownfield?
Okay, yes, so good question. You have kubectl get unmanaged config. Right? And here you see all the deviations that you have that are not managed through any intent. Okay?
Can you bring them back?
Yes. Yeah. So there is so we didn't do yet. So we are working on that. That you can actually map this to a configuration. And then but you have ISO deviation. So if you do something on the box, so that's all of these things are supported basically, right?
From different namespaces?
What do you mean different namespace? Yeah. Yes, yeah. So, yeah, Tal?
I hope I'm not disrupting. I know both Alexia and I worked on similar things, similar POCs. I have a question here, something that I struggled with.
Yeah.
Is that a lot of times, as you said, working with Yang databases is always imperative in a way. You do queries, and so for example, the struggle is with the design, right? So I see index numbers here, right? But are they like logical or specific index numbers for the device? Because the thing is, sometimes you do want to do things conditionally. First, you need a query to see what interfaces are available. And then you want to either reuse, okay, I don't want to change configurations that exist. I want to add new interfaces if they're available. But sometimes I don't want to do that. Sometimes I want to these are the exact physical interfaces that I want to I think it's always a struggle to find the design that would be, what is my intent exactly? Is my intent specific or is my intent more generic? And
so here,
support both, right?
Yeah, so in other words, you have the state side as well, right? So in the state, you can basically say, discover all the interfaces that you have on the system, right? And then you basically put a layer to say, okay, I want to use this or that or that. But so you have to build that on top of SDC, if you will, where you basically do the discover, and then you will say to it, okay, I'm going to configure this on that particular thing. So there is a layer.
High level of reconciliation.
Correct. So there is a layer on top. So what we wanted to focus here really on the basics of interacting with a device, and someone will have to tell us what he wants to do, if you will, right? That's the scope. Because otherwise, if you want to do too many things, you typically don't do anything well, right? So we wanted to focus really on that particular aspect rather than trying to boil the ocean, you see? But for example, we had a discussion with Alexis, for example, network-wide transaction, right? So for example, you could say, I want to configure or an intent that spans 1,000 boxes and one fails, and you want to roll it back, you just put a layer on top of SDC to do that. And so in other words, I wanted to build it in a way that is extendable, right? And so I'm of the opinion always that, let me finish this if you want. So to build the layer that does one thing and one thing well, and do that 100% right, and then you can easily add and compose a system that does more elements and more sophisticated pieces. Yeah, sorry, go ahead.
My question is, how do you see this, let's say, deploy when we have multi-vendor CUD or NIU?
Yeah, so this is this. Okay, so there is two pieces here. One is we support the schema, right? And we map to a schema. What we don't want to do with SDC as a project is to do a common data model across all the vendors and stuff like that, right? So again, this would be a layer that sits on top of SDC that actually has to, for example, you could build a normalized data model and then mediate towards the various implementations like DU vendor A or CU vendor B and so on and so forth. So that is, again, a layer that you would have to build on top of SDC to be able to do that. So we didn't want to focus on that part here, but so focus on the bare bone to interact, to make the Yang or the netconf and GNMI to have a declarative way of consuming it, you see? And then the mediation of doing multi-vendor and abstractions and stuff like that is in my view, a layer on top of that, right? But SDC as a building block is a way to then do that declarative interaction with the device. Okay? So, yeah, I just wanted to show just quickly that the thing is working. So, in terms of components, so I think we went over these. Schema server is basically, it's just a building block that holds schemas, and it's just an API. The nice thing, I mean, we did, that's another thing, we did an internal thing. If you want to have, let's say you have multi-vendors, and you want to have a common CLI, for example, across all the vendors, very easy. Right, so there is very nice attributes you can have. As I said, data server is a proxy, right? So it's basically, yeah, it's a stateless system, right? So you kill it and it comes back up, so there is no state inside. There is also, so that's another interesting thing, is how do we sync the configuration, right? So in netconf you have notifications. So the challenge that we have is we transact, right? How do we know? So we get, of course, the confirmation. But for example, one of the nice attributes of GNMI, you have basically, you actually get a confirmation per path. So it basically, with notification, basically tells you, this is the new value of this path, this is the new value of this path, which is actually nice. Not a lot of vendors implement it, okay? So we have various ways to sync, right? So one is periodic, but we can also do notification, but it depends a little bit on vendor implementation. And the cache is basically persistent storage, right? So so maybe practically, where does it fit? So for me, this is a potential tool that fits in what we call swim lane 3 in Nephew. So this is mainly for Neph. So it's the config side of the house, right? Now it solves particular components there. Very nice presentation of the Swisscom people. So they basically presented in KubeCon and they did a live demo as well. So they are using SDC as a GitOps tool. So they put that as part of that GitOps pipeline. So they built this layer on top that I said. And then they transact with SDC towards their 5G systems. Another way to use SDC is what I call the network-wide mode, where you actually do this. So sometimes, for example, in networking, we have use cases where we have thousands of boxes that are under this thing. So it basically has to scale very horizontally. So but even so in other words, it's designed to be able to be flexible across all of these environments. And as I said, it's open source. So here is the information. There is a Discord server. So if you're interested in contributing, and we welcome contributions, by the way, to help us get this project to the next stage. So with that, I think we have 1 minute left for questions. Yeah. Yes?
So there was a question. How do you maintain cache coherence with the device?
So
You have to stay on the device because, well, netconf assumes that the device persists state.
Yeah.
And you have a cache, which is also the state.
yeah.
How do you maintain coherence?
Yeah, so that's basically the syncing mechanism, right? So so there is a periodic syncing, which means that you have a window of opportunity where you are, so in that mode, what we do is, when we get a positive confirmation back from the transaction, right? We write to the cache by ourselves, assuming that the device is okay, right? So that's one mode. And then we sync periodically to make sure that we are up to date. What we like or what we prefer, but it's not implemented across all the vendors, is the notification mechanism. So in other words, when you do the transaction, the device will, with the streaming notification for either GNMI or will actually say per path, this is the new value that I got, and then we update the cache based on that information. That is the most scalable. But we are out of time, so maybe let's discuss that offline. Is that okay? Thank you.